Hello, I am Hans Geiger, and the project that I was a big part of was the Geiger-Marsden experiments, also better known as the Rutherford-Goldfield experiments. This is what most students nowadays will learn about in chemistry, in their chemistry class, about how they determined that the nucleus was net or positively charged, and exactly how that was determined was done by our experiments during the early 1900s. For our experiment, we were trying to determine the mass-to-charge ratio in an atomic nucleus. This is a crazy thing to think about for especially where we were at the time. Like they're really they're of course we can't just see an atomic nucleus. We have to find another way to measure how it works. So me and me as well as Ernest Rutherford, we decided to build an apparatus to determine the mass charge ratio, which was using two electrodes which can help count exactly how many air particles were being uh, vaporized in the area to help count the actual electrical impulses which helped us determine the mass charge ratio. Our experiments occurred at the University of Manchester in Manchester, England. During this time, there was also in Times Square, New York, in United States of America, had their first ever ball drop for New Year's Eve, which was a momentous occasion because that has never happened before. It was really interesting to actually watch or see if you could go see it, but nowadays it's even more extravagant because you can see it everywhere. You could just know you can see it anywhere in the world, honestly, if you really wanted to. But at that time, it was so spectacular just be in Times Square to watch that ball drop as soon as that clock hit midnight. And also another momentous occasion, which honestly might be a bigger achievement, was the 2.5 hour flight of a plane by the Wright brothers, which is just spectacular to think about because at the time we weren't really thinking too much about humans being able to fly because we're not birds. We can't fly in the air. I mean, who would have thought that would work in the end? But as you can see, a 2.5 hour flight was pretty spectacular back in 1908. In this project, as previous mentioned, Ernest Rutherford was one of the main contributors because, I mean, first of all, it's called the Rutherford's Goldfoil experiments for a reason. And the person that also helped us in the process was my undergraduate student in research, Ernest Marsden, which is the other name of our experiments, the Geiger Marsden experiments. That's where that name's come from. It's my undergraduate student that helped us throughout our research through this whole time during this project. My role in the project was I helped Ernest Rutherford design the apparatus that helped determine the mass to charge ratio in the nucleus. This was the first rendition of this was a about 2 meter long glass tube, which when some particles were sent down, it would because we knew that there was something in aluminum or gold foil at this time. We knew there's particles that would have to bounce off of. So during that, we were over time, we slowly but surely developed better ways over the next 3 years about how to determine the actual angle that the particles bounced off of the gold foil that helped us determine the mass charge ratio. Like I said earlier, the electrodes that were in there helped count electrical pulses that would directly correlate to the mass charge ratio in that nucleus. This was a huge project that happened for the physics community because this, my first rendition of the alpha particle counter that we made, the one that helps count the mass charge ratio, and that's what it was a baseline of better alpha particle counters, and over time, now they can even start counting beta particles and gamma particles, which was insane because alpha particles was one of the easier ones to read at the time. Now that they can read beta and gamma, it's insane how much technology has progressed over the years. Shortly after my experiments were over with Rutherford and Marston, I moved back to Germany actually to do some more research on radiation. Sadly, during that time, the Great War was happening, which of course everyone was pitching in everywhere, and I actually was an artillery commander during the Great Wars. Shortly after the war ended, I went back to radiation research at multiple universities throughout Berlin and just the UK area, Berlin, Germany, all that area. Just I went back to what I love doing, which was radiation research, because I was one of the main people to set the foundation of radiation research, which nowadays we can just talk about in a one semester class, which strange to think about, but it's true. Which it's great because it's great how far our research has actually gone over the time. Thank y'all for your time.